Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the problem related to friction between two blocks. That is friction resting on others. Two block friction between two blocks or friction related to three blocks, etc. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET confidently with a good rank. Student, to understand the physics or to solve the numericals, always you don't have to memorize the formula, methods, etc. Sometimes practical knowledge, general concept will required. This will help very much to solve the numericals. Now today let's start the class. I will discuss one by one. You don't require to see the another video to solve the problems related to friction of the blocks, that is block resting on others. Now step by step I will discuss. First, suppose here two blocks present, block 1, block A and B of mass m1 and m2, and there is no friction between any surface. Now a force is applied on the mass m2. What is the acceleration? The acceleration of the block B, for block B, here applied force. We draw the free body diagram here to solve this type of problem. Here also free body diagram required. Free body diagram required always. So for m2, force is applied here. Now as there is no friction, so here no friction is present. Now on m1 no force is applied, so here acceleration of block B, AB, will be force by mass F by m2, and acceleration of A will be 0. Understand this? As there is no friction, so only force F is applied on m2, no external force, no friction force act on block m1. So m1 will not move, and the acceleration of block B will be force by mass. Simple concept. Now this surface is smooth, and a friction is present between m2 and m1. Friction is present between m2 and m1. Here is friction present and this is smooth. And a block, next problem I will discuss both. There will be friction between two surfaces, this and this. First I consider that this surface is smooth and there is a friction between m1 and m2, and a force F is applied on the block m2. What happens if F is gradually increased? That is, consider the motion of two blocks. If F is gradually increased, what happens? First, friction force act on this direction, opposite direction will increase. That is, first static friction acts and force is gradually increased. Now if this surface is smooth, then two blocks, if this surface is smooth, for less force, two blocks move together after a certain value. I will discuss what is the value of F after that force. After that force, the block m2 will move separately and m1 will move separately. That is, two blocks move separately. So for certain value of F, below that force, two blocks move together. Now what is the acceleration of the two blocks? Acceleration equal to force by mass, total mass. As the two blocks move together, so take the two blocks as a whole unit, as a whole mass. So acceleration equal to force by mass. So this is the answer. With this acceleration, two blocks will move. That is, this is the acceleration of A, also as well acceleration of B. Now next, what is the maximum value of F? Maximum value of F, so that the two blocks move together. F maximum, so that two blocks move together. First, if we apply the force gradually increase from 0 to after certain value, then for less value of F, two block will be moved together. For what maximum value of makes two block move together? Now for that we draw the free body diagram. Suppose this is F, this is M2, and this is M1. Now if force is applied here, then friction force act in this direction. Friction force, now this friction force, now this force is the driving force for the block M1. The block M1 move in this direction with this force, friction force. So friction force don't always oppose the motion. Sometimes friction force causes the motion of the body. Now if the acceleration of both the body is a, now here first consider at which no external, the first consider the block at which no external force is applied. So here no external force is applied. Now the block M1 move with acceleration a. So here which force causes the acceleration? Of course the friction force. So F1 equal to M1 a. Now what is friction force? We know if the coefficient of friction is between two block is mu s into n. Normal relation in this surface is m2g, because weight act on this surface. So mu s into m2g, this equal to m1a. Now find a equal to mu s m2 by m1 into g. So this is the acceleration. Now apply here. What is the here force? What is the equation of motion? F act in this direction, F minus F1 equal to m2 into a. So F minus F1. Now put F1 equal to m1a here. So a equal to F by F equal to m1 plus m2 into a. Now put the value of a at here, we get the answer. So F will be, required force will be m1 plus m2 into a. A is what? This mu s into m2 by m1 into g. So this force, this is the maximum force for which the two blocks move together. Now if the force is greater than, if the, now this force, if this force is greater than this value, now the two block move separately. So this is the maximum force for which the two block move together. Okay, next find the maximum force. Here maximum force. So what is the, I repeat the, to solve the problem again, first draw the free body diagram. Force here and friction force act in this direction, and this is the opposing force. Now this friction always in contact surface, between two contact surface, this, if this is action, this is reaction. So force, friction force act in this direction, and on the block force is reverse. So this direction, this is opposing force, and this is now driving force. So when force is applied, this block try to move with respect to this block try to move with respect to over the block M1. So friction force act in the opposite direction. So if this is opposing force, now opposite, this is opposing force, this force act in this direction. So between contact surface, action reaction opposite. So this force will be reversed in this on the body. So now this is driving force. So now write the equation of the motion. Suppose two block move together with acceleration a. Suppose this acceleration is a. Now here only force is F1. So F1 equal to m1a. Now what is friction force? F1 equal to mu into n. So here coefficient of friction mu s into n. N is normal direction. Normal direction act on this body is m2g, because here m2g and normal direction. So this normal direction act in this on the body n. This normal direction act on the body. So mu into n equal to now for this we get a equal to this. Now what is the equation of motion of this body? F minus F1 equal to m2 into a. So F1 equal to m1a, put here, we get F equal to this. Now put the value of a at here, we get the result. So this is the maximum force applied at here for which the two block move together. Now force is greater than this value. If force is greater than this value, what happens? Draw the free body diagram. Here force is F acting in this direction. F1 maximum friction force, which is equal to mu s into, this is m2g. So this is the acceleration of block B, and m1 friction force in this direction, mu s m2g. So this is the this force causes the acceleration of block A. Now what is the acceleration of block A? A will be force by mass mu s into m2g by m1. And what is the acceleration of block B? If force is given whose value is greater than this, now AB equal to net force F minus F1 mu s m2g by m2. So this is the acceleration of block B and A, this and this. Now general case, I consider one general case. Now suppose this is block m1 and another block is m2. This is ground. Now here friction and here friction, both friction is present. First I apply the force on m1 and then I will discuss if the force is applied on m2 what happens. Suppose force is applied here, force is applied first, F is applied on m1. Now what is the free body diagram? m1. So if force is applied, then first m1 try to move with respect to m2. If force is applied on m1, then first m1 try to move with respect to m2. So if the block m1 try to move in this direction, then friction act in this direction. So free body diagram of m1 will be force, applied force in this direction and friction force in this direction. So what is the friction force? Friction force here will be obviously normal direction m1g mu s into m1g. If the force is greater, if the two blocks move with an acceleration, then we use mu k, and if they don't move, then we here use friction force mu s. So force is applied here F1. Now for m2, what happens? This is driving force, and so here suppose two friction another different. If this is opposing force, then this force is the driving force for m2. So m2 will move due to this force. If here friction force F2 equal to mu2 into m1 plus m2g. If F1 greater than F2, then this block move with an acceleration. But if this opposing force is greater, then m2 does not move. So this is the general case. First, this block try to move in this direction. So friction act in the opposite direction. Now this is opposing force, so this will be driving force. Or you consider between two contact phase. Action and reaction always equal and opposite. So if this is action, this is reaction. Now this is driving force. So for this driving force, now the friction on the ground, the motion of the block m2. So friction here equal to mu2 into this. Now what is normal reaction here? Here m1 is raised on m2. So on the ground, total weight of the block act on the ground. Here that's why normal reaction equal to m1 plus m2 dg, because m1 is raised on the m2. So total normal reaction equal to this. So friction force act in this direction. Now if the f sufficient greater to oppose the f1, so this block moves with an acceleration a1 and this block move with acceleration a2. Suppose, so what is a1? A1 equal to f minus f1 by m1, which is f minus v1 m1g divided by m1. Now if f1 greater than f2, now what is the acceleration of a2? A2 equal to f1 minus f2 by m2, which is f1 equal to mu1 m1g minus mu2 m1 plus m2g divided by total mass of the block m2. So this is the case. Force is maximum. So f1 is greater than f2, then this block move. If this force is greater than this force, this block cannot move, because the block does not move in this direction, because this is always opposing force. As the force applied here, this is action, so this is driving force. This will not driving force, this always adjusting force, opposing force. So if the block try to move in this direction, this force oppose the block M2. Suppose here coefficient of friction is mu1, here mu2. F is applied at here, F is sufficient large. So what happens if we draw the free body diagram, M1 and M2, M1 and M2, what happens? So so force is applied on M2. So this block first try to move in this direction. If the block try to move in this direction, then two surface opposes the motion of the body. So here friction force act in this direction and in this direction. Now what is the friction force? Friction force will be F1 equal to mu1 m1g, as here friction force equal to mu1 m1g. Now if this force is opposing force, this is driving force for m1, and here friction force equal to mu2 coefficient of friction mu2 into here normal reaction is m1 plus m2g. Here normal reaction, suppose n2 equal to m1 plus m2 into g, m1 plus m2g. Then here normal reaction n1 will be only m1g, because here normal reaction is only due to mass m1, and here normal reaction is due to whole mass m1 and m2, to mass m1 and m2. So here friction force equal to mu2 into m1 plus m2 into g. Okay, now if the block moves with acceleration a2 and a1, so we get a2 equal to f minus, so here net force what, this minus this minus this. So net force for block m2, what is the net force? Net force equal to acceleration of block a2 equal to net force. What is net force? F minus this minus this, minus g divided by m2. So this is the acceleration. Now for this, for block a m1 equal to driving force mu1 m1g by m1. Now if the block moves, then this will be the driving force. Now if the block does not move, then this is not driving force. So here two block will be raised. If the block does not move, then the whole body system will be raised. This will not be driving force. Remember, if that, I repeat once again, if the block move with direction, then this will be the driving force. So for this force, for this friction force, this block will move also. Now if the block does not move, cannot move, suppose force is sufficient less, so the block does not or cannot move, then this is not the driving force. So this block will rest on the block M2 if is not sufficient enough to hold system. Now if the two block move with same acceleration, and M2, here coefficient of friction is mu1 and this is mu2. This is the general case. You don't have to remember the methods or formula, just think the practical ways or general concept. So suppose F is applied first here, and suppose what is the force to such that two block move together, what we write? So M2, here M2 force is act in this direction, friction force act in this direction, because if force is applied here, then this block try to move over the surface, so friction force act in this direction. So what is the maximum force for which two block move together? Two blocks move together. First, maximum force for which two block move together, force F is applied here on M2. Next I will show if force is applied on M1, then what is the friction force, what is that force. So if the two block move together, now if the two block move together, the force F act or either act or act, that does not depend on what the force act on what block. Two block will move together, that is the force. So find the maximum force. First I discuss if the force is applied on M2, what happens? Friction force act in this direction. This will be mu1 M2G and M1. What is the friction force? Same. And here friction force equal to mu2 M1 plus M2G. Now the two block move with same acceleration A. Now write the equation of motion here. F minus this equal to M2A, and for this G equal to M1A. Now write this equation. This and this will be cancelled. This and this will be cancelled. So F minus mu2 M1 plus M2 equal to M1 plus M2 into A. This first method I discuss. First method. So this is the question. I repeat the question once again. Two blocks are placed on two blocks are placed in this direction. Two blocks are placed in this way. Friction between this block is coefficient of friction between this mu1 and this is mu2, and force fast force F is applied on M2. Now what is the maximum force for which the two blocks move together? First method I discuss. First draw the free body diagram. Force is applied here, so friction force act in the opposite direction. This is action, so reaction is opposite. This is the driving force, so this is the driving force, so friction act from the ground in this direction. Now friction force, you know, here normal direction is M2G and here normal direction is M1 plus M2G. So friction force I write this way. Now what is the equation of motion? Here F minus this equal to M2A, and here net force this minus this equal to this way. Now at what if we add cancel, F minus this equal to M1 plus M2A, so A equal to F minus by M1 plus M2. So this is the answer. By simple draw the free body diagram and we find the acceleration of two blocks. So for this acceleration of this, now what is the maximum force for which the two blocks move together? So now if we maximum force, so with this acceleration two block move together. With this acceleration two block moved. Here two question may be arise. What force is given, find the acceleration of the two blocks. So this is the answer. And if we are asked that what is the maximum force for that two blocks move together, first you find the acceleration of this block for which no force is applied. Now what is the acceleration of this block? First calculate the acceleration of the block at which no external force is applied. So here no external force applied, only friction force act. So first calculate the acceleration of this block. Acceleration equal to mu1 M2G minus mu2 into M1 plus M2 into G divided by M1. So this is the acceleration of the block. Now apply here. So force equal to, what is the force? Force equal to mu1 M2 G plus M2 into A. What is the A? A equal to this. So for this force should be applied so that two blocks move together. Now if the force is given and acceleration, you have to apply the acceleration, then this is the acceleration, and find the maximum force required so that two blocks move together. So this is the answer. Now just write the equation of motion. Separately. Now consider the three blocks resting on resting on one upon another, 3 block system. Suppose this is M1, this is M2, M3, this is ground. Here coefficient of friction mu1, mu2, and this is mu3. Coefficient of friction are given. First I apply the force in this direction. Force is applied on the M3. First consider the force applied on M3. Then what happens? What is the acceleration of the 3 blocks, or what is the acceleration of 3 blocks? So A1, A2, A3. We have to find A1, A2, A3. To find the acceleration of 3 blocks, we have to draw the free body diagram. So for M3, this is the external force. So friction force act in this direction, which is equal to mu3 M3G, because force is applied on M3. So M3 first move. M3 first try to move over the M2. So this, if the block moves in this direction, then friction act in this direction. Now on M2, I show the friction by green color. Now next, this is the opposing force. So if this is action, then this is the reaction, which is same force. Now if this force act as a driving force for M2. So here opposing force will be this, which is equal to mu2 normal direction M2 plus M3 into G. Now for M3, what happens? So this is the driving force. Now just find the acceleration of each body. So here acceleration is A1, A2, A3. Just net force by mass. What is the net force? Net force equal to F minus mu3 M3G by M3. What is the net force? Acceleration A2 equal to net force what? This minus this by M2. What is the acceleration of this block? A3 equal to net force. This is driving force, this is opposing force. This minus this divided by mass M3. So this is the acceleration. So to accelerate this force must be greater than this force must be greater than this, and this force must be greater than this. Now consider, suppose 3 blocks move together. What is the case? If the 3 blocks move together, then find the acceleration of 3 blocks. So if the 3 blocks move together, then the equation of motion is F minus mu3 M3G equal to M3A. Now here mu3 M3G minus mu2 M1 G equal to M2A. Now for this, M2 plus M3 G minus mu1 G equal to M1A. So just write the equation and add this. If we add this cancel, this cancel. So F minus 3G equal to M1 plus M2 plus M3 into A. So A equal to this by this. So this is the acceleration of the 3 blocks. This is the acceleration of 3 blocks. Now acceleration equal to F by total mass minus mu1 G. So mu1 act within the block and the ground, mu1 G. This is the answer. Now if the force F is applied M2 or M1, then the result will also be same. So remember this case. To find the acceleration of the whole system, if the 3 blocks move together, then This is the general procedure. So this is the one procedure, one method. Second method I discuss. Second method I discuss. First, one method is draw the free body diagram and write the equation of each block. If you add, then we get the acceleration. So acceleration, the value of acceleration, this NEET student or JEE main student can remember this formula for three blocks. If you are asked that three blocks move together, so what is the acceleration of the three blocks? Then this is the answer. Now if the force is applied on M2, then the result will be same. So before that I discuss the second method. Second method is second method is now if you are asked that three blocks move together, then you consider the three blocks as a whole. You consider the three blocks as a whole. So you consider the three blocks as a whole. So the whole system, this is a whole system, M1, M2, M3. Now don't consider this friction, this, because this is the whole system. The whole system force is act on the whole system F. Now what is the three blocks resting on the ground? So here friction force act this, because normal direction act in this direction. Three blocks move together if this is not with respect to this, and M2, M1 plus M2 don't move with respect to M3, but whole the three blocks move together with respect to ground. So three blocks move in the ground. So three blocks move in the ground, that is friction force act only in this surface. So here force is applied and friction force this. So three blocks, mass of the three blocks is this. So acceleration equal to net force F minus this, net force by into G by mass, net force by mass. So this is the second method. In first method there is answer, and second method answer is same. Answer is same. So two method I have discussed two method. First method, just draw the free body diagram and you get the acceleration. In second method, take, if the three bodies move together, take the three body take as a whole mass, and acceleration equal to force, net force by mass, net force by mass. Now if the force is applied at here, what happens? And if the three blocks move together, the result will be same. The just I discuss what happens. mu1, mu2, and suppose mu3. Sorry, this is mu1, mu2, mu3. Okay. Now if the force is applied here, what happens? If the force is applied here, first M2 try to move with respect to two blocks. M2 try to move. Just think practically. If force F is applied on M2, then M2 try to move in this direction. So as M2 try to move, then friction comes from two surface, this and this. So friction act in this direction and act in this direction. So this is, so here if the whole body three blocks as a whole, then what is the acceleration we get in second method? By simply net force F and friction act in this direction. So friction equal to m1 plus m2 plus m3 divided by whole mass, m1 plus m2 plus m3, that is F minus mu1 g. So this is the answer, F by m1 plus m2 plus m3 minus mu1 g. So this is the answer. Now I have discussed, and if we draw the free body diagram, and finally we get the same answer. Force acting on M2 act in this direction because force is applied here. So friction force come on the two surface, this and this, in opposite direction. This force is mu3 m1g, this force is mu2 m2 plus m1g. Now m1, this is the opposing force. So this the driving force, which is mu3 m1g and for M3, so three blocks move together, so separate, right? A. Now M1 is mu3 M1G equal to M1A. Now this F minus mu3 M1G minus mu2 M1 plus M2 into G equal to M1 plus M2 into A. Now for this mu2 M1 plus M2 G minus mu1 M1 plus M2 plus M3 G equal to M3 into A. Now write the equation. So this cancel, this cancel, so F minus mu1 so A equal to F by this, so A equal to this, so this is the result, same result before discussed. Now if the force is applied on ground mass, then the answer will be same. So you can see by you can see there by free body diagram, you can solve the problem. The answer will be same. The answer will be same if the three blocks move together. Here is a problem: 2 kg, 3 kg and 7 kg block rest one upon another. Find the acceleration A1, A2, A3 of the three blocks if a horizontal force 10 Newton is applied on 2 kg block first, then 3 kg block, then 7 kg block. AC Verma book problem. So what is the answer? The first 10 Newton applied on 2 kg block. So draw the free body diagram. 2 kg block, this is 2 kg and force 10 Newton is applied here. 2 kg over 3 kg over 7 kg over 7 kg over 7 kg. So 2 kg, 3 kg, 7 kg block. Draw the free body diagram. Now 10 Newton act on the 2 kg block. So what is the free body diagram? What is the force acting on each block? First 2 kg block move with over the surface 3 kg, 2 kg move, 10 Newton act, so 2 kg move. So think practically, then you can solve the problem. 10 Newton move in this way, so friction act in the opposite direction. So what is the friction? Friction equal to F1 mu mg, mu equal to 0.2 m 2g, that is 4 Newton. So 10 Newton act in this direction, 4 Newton force, opposite force act in this direction. So net force we get, this is A1. Now what is the force acting on 3 kg block? So this is driving force 4 Newton. Now if this is the driving force, then friction force act in this direction, opposite direction. What is the friction force? Friction force equal to mu2 is equal to 0.3 into m1 plus m2. So 2 plus 3 equal to 5, 2 plus 3 equal to 5, 5 into 10 which is 15 Newton. So this is the friction force. So here friction force 15 Newton acts. Now what is the friction force act here friction force 0 because coefficient of friction is 0 given. So here friction force is 0. Now what happens? The 2 kg block, the net force acting on 2 kg block, 10 Newton from this applied force and friction force opposite direction 4 Newton. So net force equal to 10 minus 4, that is 6 Newton. Now acceleration of A1 equal to net force by mass, that is 3 meter per second square. So this is the acceleration of A1. Now what is the acceleration of A2? So A2, 4 Newton acts in this direction, 15 Newton. So student think that here force is maximum, so A2 moves in this direction. This cannot happen because this is the friction force. Friction force cannot drive the body. This is the driving force. If this force greater than this, then the body can move. I have discussed earlier that this force to move this driving force must be greater than this force. 4 Newton act in this direction and 15 Newton act in this direction. So 3 kg cannot move over the 7. 3 kg cannot move over the 7 because friction force is sufficient. Now 3 and 7, 3 and as 3 and 7 cannot move, 3 cannot move over 7. So 3 and 7 move together. So 3 and 7, take 3 and 7 as a whole, and this whole and the whole system 4 Newton act here. So here external force, because here friction force is 0, so here 4 Newton is the driving force and 3 and 7 move together. So force equal to mass into acceleration. So A equal to 4 by 10, that is 0.4. Now so acceleration of 3 and 7 same, that is A2 and A3 equal to 0.4 meter per second square. So this is the answer. Simple solve. First, 2 kg block, apply the force 10 Newton. 10 Newton external force act in this direction, friction force act in the opposite direction, which is equal to mu mg, that is 4 Newton. So net force equal to 10 minus 4, 6. Acceleration equal to net force by mass, that is 3. Now what is the friction force act on 3 kg? This is if this is action, this is reaction, this is driving force. So this is reaction, that is this is driving force. Now if this force act in this direction, then friction act in the opposite direction, which is equal to 15 Newton. Mu here normalization equals to 2 plus 3 into g, that is 5g, 0.3. So 15 Newton comes. So as 15 Newton greater than 4, that is 3 kg cannot move over the surface 7. So 3 and 7 take as a whole mass. Now external force F is 4 Newton. So total mass equal to 3 plus 7, 10. So net force equal to mass into acceleration, A equal to this, that is 2 block 3 and 7 kg move with an acceleration same, with same acceleration 0.4. So A2 equal to A3, that is 0.4. Now block force is applied here. Force is applied here. So what happens? That is, I have discussed that if the external force act on this body, then this body try to move in this direction. First this body try to move in this direction. So friction comes over the two surface which opposes the body. So here friction comes. Now this friction is equal to mu 0.2 into mg, 2 into 2, that is 4 Newton, and this friction is mu that is 0.3 into same way 3 plus 2, 5 into 10, that is 15 Newton. Now here friction force 4 plus 15, 4 plus 15, total friction force 19 Newton. Now external force 10 Newton. So 10 Newton less than, as 10 Newton less than 4 plus 15 Newton. So the external force cannot drive the 3 kg because friction is greater. So 3 kg, as 3 kg cannot move, then 3 kg cannot move over 2 and 7. So 3 and 2 and 7, the whole system move together, because 3 cannot move. So 2 and 7 cannot move separately. So the whole 3 blocks move together with same acceleration. That is, now what is the, if the 3 blocks as a whole, then external force 10. Now here friction force equal to 0. So total external force equal to 10 and mass equal to 2 plus 3 plus 7 into A, which is equal to A equal to 10 by 12, which is 5 by 6 meter per second square. So now 3 blocks move with same acceleration, that is A1 equal to A2 equal to A3 equal to 5 by 6 meter per second square. 7 kg, 3 kg and 2 kg. 7, 3, 2. Now 10 Newton applied on this. So what happens? Friction force act in this direction. Here friction force 0. Now friction force act in this direction, which is equal to 15 Newton. 5.3 into g, that is 15 Newton. So friction act in this direction, and here friction in this direction. So this is x, this is. Now here also, as external force is less than 50 Newton, 10 less than 50 Newton, so 7 kg cannot move 3, 7 kg cannot move over the 3, that is 7 and 3. This is 50 Newton, so this is 4 Newton. Now first friction force act on this on the 7 kg in this direction, which is greater than 10 Newton, so 7 kg cannot move. As 7 kg cannot move, 7 kg cannot move, then 3 and 2 also don't move with respect to 7, that is whole the 3 body now move together, 2 3 7, because 7 kg 10 Newton first act on 7 kg, but friction here 15 Newton, which is greater than 10 Newton, that is friction prevents the motion of the body 7, that is first 7. Now 7 don't move over the 3, that is 3, 3 2 and 3 and 7, the whole 3 blocks, the 3 blocks move together. Now the 3 blocks as a whole take and 10 Newton act in this direction, so here friction is equal to 0, 7 and 3 don't move with respect to other, so as 3 don't move, then 2 also cannot move. So remember that if a suppose 2 block is present here and an external force cannot move this block, then B cannot move, this is general concept. If A cannot move, then how a B can move? So this is the practical concept. You don't have to consider the friction force. If A cannot move, then how can B can move? So this is general concept. So 7 first cannot move over the 3, because friction force is here. So 7 3 take the 7 and 3 as it together, so 3 cannot move, so 2 cannot move, that is 7 3 2 act as a whole system. Now the whole system, take the whole system this way, take the whole system this way. Friction external force is applied 10 Newton here, but here friction force is 0. So the if you consider the whole system of mass 3 plus 12 kg and force is applied 10 Newton, here friction force is 0, so force equal to mass into acceleration, so A equal to 5/6 meter per second square, that is 3 blocks move with same acceleration, which is equal to this. Student, this is the end of the class. To get such type of video and continue the whole theory class, subscribe my channel. Thank you.